All right, we are on section 6.2. We are still working with exponent rules. Now we are going to talk about what happens when we divide variables with exponents, and we'll also talk about the negative exponent property. So, similar to our multiplication property, when we divide variables with exponents, we will take the variable with the exponent in the numerator and we'll subtract the exponent from the denominator. So, an example of this, if I had let's use something else. If I have x to the power of 5 divided by x to the power of 2. This would simplify to x to the power of 5 minus 2. So I'm taking that exponent from the numerator and I'm subtracting the exponent from the denominator. So this answer would be x to the third. Okay, so multiplying variables with exponents, we add the exponents together. Dividing variables with exponents, we subtract the denominator from the numerator. Okay, so that's the division property. And now the negative exponent property, basically, if you ever see a variable with a negative exponent, this is the same as writing 1 divided by that variable with the positive version of that exponent. The flip side of that, literally the flip side, if I have 1 divided by a variable with a negative exponent, I will then flip it to the numerator, a to the power of 1, and I'll change that exponent to be positive. So an example of the top rule would be if I had, let's say, 2 to the negative 1 exponent. This would be the same thing as writing 1 divided by 2 with the 1 exponent. Or, since it's just an exponent of 1, I could just write 1 over 2. And then the other side of this, let's say I had 1 divided by 4 with the negative 2 exponent. This would be the same thing as writing 4 with the positive 2, or 4 squared. Okay, so if you have a negative exponent, you take that term and flip it to either the numerator or the denominator, whichever one it is not currently in. All right, so let's get some practice with this now. All right, so if I have, over here in example A, x to the power of 4 divided by x. So we can think of that x in the denominator as having an exponent of 1. And if I want to simplify this, I can take my numerator, so x, and take my the exponent from my numerator term and subtract the exponent from my denominator term. So if I simplify this, I would get x to the third. So remember, dividing variables with exponents, we subtract the denominator exponent from the numerator one. Okay, let's try something a little more complicated. So just like when we multiplied terms with variables and coefficients, and we would multiply the coefficients first, if we're dividing terms like that, we're going to divide the coefficients first. So the very first thing I'll do is say, what is 8 divided by 4? That would get me 2. Now I have my variable a. My numerator exponent is 6. My denominator exponent is 2. So this would simplify to 2a to the 4th power, 6 minus 2. All right, try C on your own and see what you can get. Okay, so your exponent in the numerator is technically a 1. So x to the 1 minus 4 would get you x with the negative 3 exponent. Now, technically, that is the correct answer, but if you wanted to simplify it, you don't want your final answer to have negative exponents. So we would use the negative exponent rule, and we could rewrite this as 1 divided by x to the third. So that would be the absolute simplified answer. If you wrote x to the negative 3, you'd probably get most of the points, but it's technically not correct if you have a negative exponent. All right, let's take a look at D. So we have one coefficient, and then the rest is just a bunch of variables. So since there's no coefficient in the denominator, it's technically 4 divided by 1, which is just 4. Now I have an A in the numerator, but I don't have any A's in my denominator. So I just have one A, so that doesn't change. Now I have B squared in the numerator, but I don't have any B's in the denominator. So again, there's nothing to do with that other than copy the B squared. And then I have a C to the negative 3 in the denominator, but there's no C term in the numerator. But I don't want a negative exponent, remember that. So since it's a negative exponent in the denominator, I will flip it to the numerator so that it is positive. So our final answer for this one is actually just 4ab squared c to the third. So sometimes there aren't any variables that you can combine, but we were able to move the c with a negative 3 exponent to the numerator. All right. E is a little similar to the last one we just did, but it's a little more in-depth. I want you to try this one on your own. So very similar to the last problem, just a few more moving parts. See what you can do. All right, so your answer might look a little different than mine. Remember what I said a couple problems ago. We don't want our final answer to have negative exponents. So we don't want to just move everything to the numerator because then we would have some negative exponents. So I moved the a to the negative 2 into the denominator, so it became a to the positive 2. And then I moved the d to the negative 5 in the numerator to make that exponent positive. Okay, so if you moved everything to the numerator, that's not exactly right. We need the exponents to be positive. All right, now let's take a look at example F. Okay, so I notice I have a 2 in the numerator, but I don't have any coefficients in the denominator. So I will have 2, and then I have x to the third in the numerator and x to the negative 2 in the denominator. So I'm going to do this, I'm going to take a couple extra steps. So I have x to the third, but then I also had x to the negative 2 in the denominator, so if I move it up, that becomes an x squared. Okay, we'll combine those in a little bit, but I'm just trying to get everything organized. Then I have y to the fifth, and then I have a y in my denominator, so that's y to the 1, but I want to combine all of my like terms. So because they're both y, I need to move them all to the numerator. So if it's y to the positive 1 in the denominator, it would be y to the negative 1 in the numerator. Okay, so now let's look at how we can combine these. So I have two x variables with different exponents, and these x's are being multiplied. So I still have my 2, whoops. I still have my 2, and so then I will have x to the power of 3 plus 2, which in this case would simplify to 5. Then I have my y terms, and they have two different exponents as well. So again, I'm multiplying those, so I'm going to add the exponents. So I'll have y, and then 5 plus negative 1, or the same thing as 5 minus 1, will give us an exponent of 4. So this was an instance where we wanted to move all of our terms to the numerator, the only reason being I wanted to combine all of my x's and all of my y's. Okay, so in those previous problems where we left stuff in the denominator is because in the original problem, all of our variables were already combined as much as they could be. I only had 1a, 1b, 1c, 1d, so the only thing left was to get the exponents positive. Because in this problem, I had an x in the numerator and the denominator, I had to combine those, so that's why I brought them up. And then same thing with the y's. Okay, so I know that can be a little confusing, but after some practice, it'll become a lot more easy to remember. All right, these ones look like there is a ton of work to do, but I think these are going to be quicker than you think. So let's take a look at G together. First thing I notice is I have a coefficient in the numerator and the denominator. That's great. So 5 divided by 10. You might remember with fractions, I'm going to write off to the side here, we can think of this as just 5 divided by 10, so let's not look at the variables for now. This is the same thing as 1/2 actually, because if I divide 5 by 5, that gets me 1, and if I divide 10 by 5, that gets me 2, okay? So that's actually the same as 1/2. So with that knowledge, I'm going to write this as 1/2, and then I'm going to continue this fraction. So when I have variables that are the same, so I have an a in the numerator and an a in the denominator, remember my end goal is to make my exponents positive. So I have a -3 and a -2. So which of these numbers is bigger? Because that's the number we want to move. Well, 3 is larger than 2, so I'm going to move this a exponent down into the denominator, and we'll combine them there, okay? So I know that's a little confusing, but here's what I'm doing. So I have a to the -2 already in my denominator. I'm going to use the negative exponent rule to move a to the -3 into the denominator. So this sign will change, and it'll be a +3. So now I have a to the 3, okay? So now I have taken care of my a variables, so I'm going to cross them off. So next, we need to work with the b variables. So if I look, I have a positive b, or a b with no exponent, so it's b to the 1. And in the numerator, I have b to the -2. So if I want my exponents to be positive, I should move this one to the denominator, because then I'll have b to the +1, and then this will turn into b to the +2. So let's move those down as well. I'm going to use a different color just so we can see the differences. So I have b to the 1 already, and I'm moving the other one into the denominator. So that's b to the 2. Okay, so now we've done the b's. Now let's do the c's. So again, I look at these, they're both negative exponents, so I'm going to move whichever one has the larger number. In this case, 4 is larger than 2, so I'm going to move this one into the denominator. So let's I'll use yellow here. So we're going to have c to the -2 was already in the denominator, and then if I move c to the -4 into the denominator, the sign changes to be positive, so I have c to the +4. Okay, so I know this can look a little messy, but we're about to simplify. So the only thing in my numerator is 1. Everything else is in the denominator. So I have a 2, then I have a, and then it's my 2 exponents. Since I'm multiplying these variables, I will add these 2 exponents. So I'm multiplying a and a, so it's the same variable. I add the exponents, so it would be -2 plus 3. And then with b, I have b, and then I'll add those exponents, so 1 plus 2. And then c will be -2 plus 4. So all I'm doing is I am adding the respective exponents for each different variable. I hope you can see that. If you have questions on this, or if this is at all confusing you, please ask your teacher and let them talk to you a bit more about it. It's very important that you understand how we're getting from here to here with our exponents. So the last step, I just need to combine the respective exponents. So again, 1 is the only thing in my numerator. I have a 2 as my coefficient in the denominator. If I combine my a exponents, -2 plus 3 is 1. So I can write a to the 1, or just a if you want. I'm just going to use the color blue since I'm writing my final answer now. So then b, I have b to the 1 plus 2, so that would be b to the third. And then I have c to the negative 2 plus 4. So negative 2 plus 4 is going to be just 2. Okay, I know that was a ton of work, but we finally got to our answer using the exponent rules that we know. Okay, let's do one more together, and then I'll leave the last one as homework for you. So I notice I don't have a coefficient in my numerator, but I do have one in my denominator, and it doesn't have an exponent, or it doesn't have a negative exponent, I should say. So that 3 will stay in the denominator. And then I see my x variables. So I want to move them to the part of my fraction bar where they will be positive. So I have a positive 3, and this would be a positive 1. So since 3 is the larger number, I will move the other one up. So I'll have x to the 3, and then I'm moving up x to the 1. So the negative exponent rule will turn it to a negative 1. So then I'll have x to the negative 1. Okay, so those are my x variables. Next is the y's. So I have y to the negative 4 and y squared. So because y squared is positive and this one's negative, I'm going to move this y to the denominator. So that way the variable stays positive after I add. So I'll use different colors here. So y squared was in my denominator, and then after I move y to the negative 4 to the denominator, it becomes a positive 4. And then I have the z's left. So z squared, z to the negative 4, I will move this exponent to the numerator and make it positive. So we have z squared, and then z, it will become z to the positive 4. And that's those. All right, so now we just need to do some simplification. So x to the third and x to the minus 1, so I will add those together in the numerator. And then same thing with the z's. So I have z squared and z to the 4th. So I will add 2 and 4. If I go to my denominator, I still have my 3. And then we have y, and then we add the exponents. All right, last step is just to combine those numbers and the exponents. So my numerator, x to the 3 minus 1 is x squared. Z to the 2 plus 4 is z to the 6th. Denominator, we still have our coefficient 3. And y to the 6th. So you're moving your exponents so that you can keep them positive. If any of your exponents end up being negative, that's okay. You just need to flip it to the opposite part of the fraction bar to make it positive. All right, last problem. I know it looks like a big one, but you can do it. Problem I, try this one on your own, pause the video. Once you got it, check your work with mine. All right, so I got my final answer to be in my numerator, 8 times a to the 5th times c to the 7th. And in my denominator, I had 3 times b to the 6th. The reason I have 8 and 3 is because I noticed 6 divided by 16, this fraction simplifies to 8/3. So that's where those numbers came from. And then I just followed my process with my variables and simplified there.